Good morning friends. Today we are going to discuss about three-dimensional force system or space force system. Before that, let us discuss how we used to resolve force into two components. So F is given here. We know x and y axis. Theta x is given. If only theta x is given, we will say that fx equal to f cos theta x and fy equal to f sin theta x. But what if theta x is assigned like this and theta y is assigned like this? You can simply say fx equal to f cos theta x and fy equal to f cos theta y, because we assign cos to a component of the force when axis, the angle between force and one of the axis is known. Now if this is the system which is given theta y theta x separately, you can simply say that fx equal to f cos theta x and fy equal to f cos theta y. Now to imagine force in 2D, imagine a wall in your room. Imagine vertical line as y-axis, imagine bottom line of your wall as x-axis, and imagine you have drawn a line from the starting point or from origin. Now that line represents force, line of action of force, and we resolved that kind of force system for our calculations. Now in case of three-dimensional force system, I need you to again imagine the walls. In this case, imagine your room and imagine any two adjacent walls. Now the line joining two adjacent walls, the vertical line is your y-axis, bottom line of one wall is your x-axis, and bottom wall of remaining wall is your z-axis. Now imagine from the intersection point an inclined line is drawn. Inclined line is drawn. Now that inclined line which is acting in space, remember this inclined line is in space, so it will have the end point of that line. Imagine this is a force line, line of action of force which is drawn. Now that particular line has starting point and end point. Now the end point is having some sort of distance from this floor. Basically, if you imagine it as your room floor, now this particular point, end point, will have some sort of distance from x-axis, some sort of distance from z-axis, and similarly from y-axis. So it will have endpoint have coordinates as x, y, and z, and origin will have coordinates at 0, 0, 0. Similarly, if you imagine this line in space, this will create some angle with y-axis, some angle with x, and some angle with z-axis, and that is what theta x, theta y, and theta z indicates here. So it is very simple. If you know axis of the line of action of force with respect to axis, we assign cos to it. By using that principle, fx equal to f cos theta x, fy equal to f cos theta y, and fz equal to f cos theta z. So what we have done here, we have resolved force into three components. In 2D we resolved it in two components. In 3D we are going to resolve it in three components: fx, fy, and fz. Now resultant is equal to under root fx square plus fy square plus fz square, and from this equation cos theta x equal to fx by f, cos theta y equal to fy by f, and cos theta z equal to fz by f. Now f is the resultant of this force system. So if you know theta x, theta y, and theta z of a single force, you can easily determine its x, y, and z component, and vice versa. If you know x, y, and z component, and if you know the angles, you can easily determine value of f. Now there will be a question in your examination, there can be a question rather, prove that cos square theta x plus cos square theta y plus cos square theta z is equal to 1. To prove that, you need to draw this figure. To understand it better, what I meant by force acting in space, I have uploaded one more video, please go through that. So from this equation, cos theta x equal to fx by f, theta y equal to fy by f, and so on. So you can show cos square theta x plus cos square theta y plus cos square theta z is equal to 1 by squaring these three equations and then adding it. So we get this equation, cos square theta x plus cos square theta y plus cos square theta z. You simplify it. We know f is equal to under root fx square plus fy square plus fz square. Square it, put it here, and we get cos square theta x plus cos square theta y plus cos square theta z is equal to 1. Now in case of space forces, do remember that we have three axes x, y, and z. and we have other three axes also, minus z, minus y, minus x. The angle between like axis, mean positive x, positive y, positive negative z, is 180 degrees, and angle between unlike axis, any unlike axis, is 90 degrees. So positive x, negative y, we know it is 90. Positive x, negative z, positive x, positive z, positive x, positive y is 90 degrees. You need to imagine these figures in 3 dimensions, and then only you can understand it better. So remember this particular principle. Now in three-dimensional force system, we generally represent force in vector form as F bar is equal to Fxi plus Fyj plus Fzk. Now I is the unit vector assigned for forces acting along x-axis, y for y, j is the unit vector, and for z-axis k is the unit vector. So remember, to represent force in vector form, we use F bar is equal to Fxi plus Fy j plus Fzk. I is for x-axis, y is for j-axis, and k is for z-axis. So I for x, j for y, and k for z-axis. And this is the example how we represent it. So this force is acting in downward direction, but it is parallel to y-axis, so it is represented as minus 10 J Newton. This force is acting parallel to x-axis, so that's why 5 I Newton, and this force is acting along z-axis, so that's why 15 K Newton. One more example is also explained here. Now there is one more definition called unit vector. Now unit vector is equal to x2 minus x1 plus y2 minus y1 plus z2 minus z1 ijk divided by under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Now to imagine this, imagine a room, imagine the axis system that we discussed earlier, and now hold a pen, pencil or a scale in your hand. Imagine it as a single line. Now that pen, pencil, whatever you are holding is having one starting point and one end point. It's up to you which point to assume what. So assume it at one point as starting point and assume one point as end point. Hold it in any manner you want. So both the points will have coordinates, and imagine that particular pen, pencil, whatever you are holding as line of action of force. Now to determine unit vector, all we need to do is to determine coordinates of line of action of force, starting and end coordinates, and use this equation to determine unit vector. Now remember, this unit vector is very useful when we need to convert force into ijk format, that is in vector form. So many a times what will happen, they will have this axis system and they will show you force 100 Newton with coordinates 1, 2, 3, and let us say 4, 5, 6, and they will ask you to express that force into ijk form. So in that case you need to use this equation. This is second method to represent force in ijk form. Now we have already discussed the equation for resultant. It can be also denoted by notation F, or you can use notation R. These are the conditions for equilibrium. Only one condition is added from the 2D system that we discussed in previous lecture. Now we will discuss some numericals. Now the major part of resolving the force into three components is there in your syllabus. Now there are three methods. Today we are going to discuss only one method. When angles of the force with respect to axis are given. So in this question, find x, y and z component of force shown is asked. So force is shown, the angles with respect to x, y and z axis are shown, and we are asked to determine if this is the force, what are its x, y and z components. So it is very simple. Fx equal to f cos theta x, fy equal to f cos theta y, and use these equations to get these values. And once we get these values, you can express it in terms of ijk format. Remember, x axis is related with I, y axis is related with j, and z axis is related with k vector. So that's how this 836.66 Newton is resolved into three components. This particular line is wrong. Forget this line. By mistake I have written this. In second question, determine the magnitude and direction of the force. It's exactly opposite question where Fx, Fy and Fz are given. This force is explained in terms of Fxi plus Fyj plus Fzk. From this you can easily find out which is Fx, which is Fy and which is Fz. You can easily determine the resultant, and we know cos theta x is equal to Fx by f. So cos theta x is equal to cos inverse Fx by f. By using this simple equation we can get theta x, theta y and theta z. Now if you use minus 250 into this equation, you will get 114 degrees. If you use plus 250, you get 63.9 degrees. So but 116.1 and 63.9, it's like cos 116 and cos 63.9 both are same. So you can use any value you want. Because it is negative 250 Newton, that's why it is mentioned that it is with respect to negative z axis. In second question, theta x is given, theta y is given. We are asked to determine theta z, and also Fz is given. So theta x, theta y and force, component of the force in along with z axis, with respect to z axis is given. It's minus 52 Newton. We are asked to determine theta z and Fx and Fy. For that we have one equation we already discussed, cos square theta x plus cos square theta y plus cos square theta z is equal to 1. Put these values. Now you will have two values theta of theta z, one with negative axis and one with positive axis, as cos square theta z will be the equation, right? So you will have two equations when you determine the square root, plus and minus. So it's up to you which value to use, because cos 61.78 and cos 118.22 both are having same values, and it is depicted here what it means. This is negative z axis, this is positive z axis, and this is the force. And the value does not matter whether it is with respect to negative or positive z axis. It's up to you. And once we know the value of theta z, we have the equation f cos theta z equal to fz. By rearranging that, we get equation cos theta z equal to fz by f. Put this value and you will get value of f. You can use any value you want. Once you know value of f, we know fx equal to f cos theta x and fy equal to f cos theta y. There are, as I said, there are three methods. This is one method. In the next lecture we will discuss how to resolve the force into fx, fy and fz format, how to get these three values when single force are given, but instead of angles when coordinates are given. And there is one more method, when projection of the force in plane of two axes is given. So there are three methods. Today we are done with first method. In the next lecture we will discuss remaining two methods. If you have any question regarding space force, you can always contact me. Thank you.